All right. So, important update. I'm just going to read this. Our simple harmonic note motion test will be next week. It'll probably be Wednesday or Thursday, one of those 2 days. We will be using a very different format for this one, and we will do so for all tests that follow. This will be good prep for you for AP exam purposes. I'm borrowing a procedure used by our biology/AP environmental science teacher and science department chairperson, Mrs. Ensley, that is designed to ensure equity for you guys and online learners. That's been my big struggle. I'm not going to let you guys not use your notes when I have no control over where where online students, of what they do, right? It's not fair. So, from now on, tests will not be open notes, and so certain procedures will need to be followed. Most importantly, online students will need to take the test during their scheduled class period. Do I have anyone on Zoom? No. Other instructions are at the end of today's module. I'll go over those as well. Please read them. Download this. You will have to do this. Download the AP Classroom lockdown browser and ensure that you are ready on test day. Next week, we will spend a day reviewing for the exam, and we will test these new procedures just to make sure that they're copacetic before we actually do our first test using this procedures. From what Mrs. Ensley told me, she's done her tests like this for quite a while now, and it works. The only students that it doesn't work for are the ones that are at home and they don't sign up for the Zoom meeting, in which case online students that do not take the test according to these procedures will receive a 0 for the exam and will need to do the retake for a maximum score of 70. So it's important that you online learners that are not in this class, because you guys are not online learners, follow that. Okay, so what you have to do, your exam will occur during the class period designated in Skyward. Obviously your third period, so it's 9:20 to 10:08. I'm going to read the face-to-face students. I'm going to read the specifics for virtual students too for purposes of the video. But for you guys, your exam will take place during a regular class period. When you arrive at class, sit in your usual assigned seat, but move the chair to the front of the desk so you're facing the back of the classroom for obvious reasons. Turn off your cell phone, place it in your bag and your bag on the floor, or just silence it, put it in your bag, put your bag on the floor. You may only have your device and a calculator at your desk. I will have a formula sheet for you for that day where you can keep it if you want afterwards. If you're on a district-owned Chromebook, you will need to select the apps button at the bottom of the screen prior to logging in. You might have done this before. And then you select the College Board app from that list and log into AP Classroom. You will automatically be in the lockdown browser when you do that. Okay. If you're on your own device, you will log into AP Classroom, go to your assignments where the test will be, and when you open your exam, the lockdown browser will open. I'm requiring the lockdown browser for the next test, which means you'll have to have the lockdown browser installed. It is essential that you have the lockdown browser loaded and checked prior to your exam time, and then repeat that because it's very important. And then below that, lockdown browser, downloading and access instructions. So here's instructions on how to do so. Please note, if you have your own personal Chromebook, you will need to check out a Chromebook from the school. If that's the only device you have, your personal Chromebook, then it's not going to work. The lockdown browser, the AP Classroom lockdown browser will not work. Why? I have no idea. It's Chrome. It's Google. Who knows? Right. So yeah, if you are using your own personal Chromebook, you're going to have to check one out from the school. If that is you, please let me know ASAP, and I will contact Angie Magana, Miss Magana, to see what we need to do. Is that you, Mr. Martini? People are pointing at you. Huh?
I already have the lockdown browser from another class.
And it works? Okay, you're good to go. You may not use your phone, the internet, or notes on the exam. We need to start getting ready for the AP exam, and now that I have a protocol that actually appears to have worked for other AP classes, we're going to follow it. I'll be watching the lockdown browser, and the lockdown browser will notify me of any suspicious activity. Pretty much the same for online learners, but you'll need to be logged into the Zoom meeting. A link will be posted on, that shouldn't say tomorrow, next week's testing page in Canvas, at least 5 minutes prior to the exam start time. You'll probably want to log in with your phone. Log into Zoom with your phone, and then prop your phone and Zoom on it. It is unlikely that you'll be able to have the Zoom tab open at the same time as the lockdown browser. So you'll be doing your test on your computer, but then you'll be on Zoom on your phone. Apparently, that's the easiest way to get this to happen. This is the only way for me to make sure you guys aren't cheating. So it's got to be this way. If you're not on Zoom with your camera and sound on for the entirety of the exam, your exam will not be scored. No one in my classroom will be able to see you. You'll just be on my laptop here at the front of the room. They won't be able to hear you. I will have headphones in, so I'll be able to hear you. And you have to have Zoom on with your camera and the sound on for the entirety of the exam for your exam to be scored. Same thing, district-owned Chromebooks. If you're on your own device, same thing. Lockdown browser you'll have to have, and you cannot use your notes. And that's what I'm looking for. I'm looking to see if you guys are using your notes. The lockdown browser will prevent you from going to other websites. But if I see you looking around or seeing light coming from another side and you looking over there, then that tells me you're looking at another computer, and that's not okay. Yeah. All right. So, again, we're going to do a little test run on this next week while we're reviewing. So keep an eye out for the instructions how to do that, or when we're going to do that on next week's modules. But again, test at the earliest Wednesday, but more than likely on Thursday. So, yeah, there's that. Now, not only that, I want to talk about this lab a little bit. I will be extending the due date to Sunday night because we were talking about it last period. Some students were seeing relationships that do not exist, that literally do not exist, and it's easy to be fooled if your vertical scale is really, really small. Okay? So if I graph period versus mass, it doesn't look like there's much of a correlation here, right? Some students say it might look like a parabola or something like that. I'll tell you right now, there shouldn't be any correlation between mass and period. You change the mass, the period should not change. Okay, so that's an answer for you right there. Now, what tells you that, and if you were thinking hard, you might have looked on your vertical axes and noticed the numbers. I see 1.417, not 0, 1.417, and then I see 1.423, right? 417, 423, that's a difference of 6/1000ths of a second. That's very small amount of time. So the difference between these data points, even though on the graph it looks like they're all over the place, is very small, meaning that there really isn't a correlation here. And how you can see that, the graph, and this is why I'm giving you an extension on the due date, because I didn't tell you to do this, so you might have seen something like this. But if you go up to the gear and you click include origin, then it's going to zoom out so that you see so that it puts the origin on the graph. And when I do that, look what happens. Right? Now that it's pretty much completely horizontal. Now that I go from 0 to 1.4, they're all essentially right on top of 1.4. And so if I do a curve fit, then I'm essentially going to get a straight horizontal line, which tells me when I vary this, it doesn't affect this at all, right? Make sense? Okay. So that's the conclusion you should have come to when it comes to mass versus period. Another thing that you might have noticed is that whenever you're varying the release angle, for small angles, for angles less than about 15 degrees, changing the angle doesn't affect the period. Not by much, not by really any measurable amount. You might see some discrepancies there, but it really doesn't change things much. It's only when you get to larger angles that you start to see a different period. You start to see increasing periods. So, we will talk about that on Monday. Just make an observation of that. Yes, it's probably going to look kind of linear, but for reasons that we'll talk about on Monday, there are important considerations there that are actually pretty beyond the scope of this class. But I just want you to realize is that for small angles, it's pretty much the same. For larger angles, then it starts to increase a little bit with increasing angles. So if you got that, you're good. And when it says what are the unit or like interpret the slope for that part, well, it's going to look linear. So your rise is going to be in seconds. Your run is going to be in degrees, right? So it's like seconds per degree. So you could just say, well, that slope tells me that for the incremental increase in the angle, I get an incremental increase in the period. And again, I would mention this, for if my data bore it out, which it should if you took careful measurements, for angles that are larger than about 15 degrees. Lastly, when you are interpreting your length versus period, or your period versus length graph, which is the one you should be linearizing, when you're interpreting that one, you can actually come to a conclusion as to what the slope represents. Okay, and that's what I'm looking for. We know the equation. It's on your formula sheet. The period for a pendulum as related to its length is this. Remember, we did something very similar, or I did on Wednesday, for the period of a mass spring oscillator. And when I linearized the graph of period versus mass, I actually was able to use that slope to determine what the spring constant was. Okay? So when you interpret the slope of your period versus the square root of length graph, when you linearize it, what quantity should we be able to determine by looking at the slope? Little g. Yeah. And so that's how again, you don't linearize just to linearize. You don't linearize just because I tell you to. You linearize because it's a very useful tool in the realm of science and engineering. It tells you when you linearize a nonlinear graph, I can figure out g by analyzing the actual graph of period versus length, but it's going to involve a lot of work, and it's going to involve mathematics that we haven't really dealt with yet. If I linearize it, I can very easily, if I know how to deal with the equations for lines, I can very easily come up with some interesting information. In this case, the square root of, in this case, g. I can set the equation, or set the slope equal to 2 pi over the square root of g. And then I can figure out what g is. Okay. So, the next lab that we do, we will linearize again, so I'm not going to be as explicit as what I'm telling you now. But just understand that you don't linearize just for the sake of linearizing. You linearize so that you can take that slope and then determine something useful. Okay? All right. Those at home, goodbye.